Hello. So we're going to do another coding question today. Somebody pointed out that maybe I should use Java, and that makes sense. I think a lot of people start out with Java. That's what they learn in school. That's what they first come encounter with. I haven't actually used Java for a while, probably since school. So there's going to be a lot of Googling Stack Overflow for me in this one. Um, in the meantime, as I'm doing this, I'm also actually conducting a bunch of mock interviews for anybody who wants them. And I'm recording them all anonymously. So once I've got like a good set of interview performances, I'm gonna upload those so that there will be a wide range of um, performances for the same questions. You can kind of see what people ask questions on, what people stumble over, um, what other people code like, things like that. And because I'm going to do a Java question that I haven't done before, I'm going to pick an easy one today. Um, ooh. There's not a whole lot of easy ones, apparently. Okay, wow, this is a really long question. But let's take a look. Okay, it sounds like we're given a 2D array, and we essentially want to reflow it into another shape. This sounds simple enough, but as I'm parsing this, um, I'm coming up with a bunch of edge cases. Um, so I'm parsing this question as essentially the original row and column, the area of this, so this is 2 by 2, that's 4 numbers, has to match 1 times 4. Otherwise, what do you do with the either if there's not enough holes to put numbers, or if there's too many holes and there like it wouldn't be a complete rectangle afterwards. So I'm just going to read this again. The same row traversing order as they were. So right, so we would go through this left to right from row to row. And as I'm parsing this, I think its definition of what is possible and legal is what I said about essentially they occupy the same area. There's the same number of um, numbers in the input and the output rectangle. And whereas here, this is 4 numbers, but 2 times 4 is 8. So we can't really fill that. Okay, I'm going to go with that assumption, and it seems rather straightforward. Um, so it feels like I would just iterate through every row and put it at the next, like wherever that is. And so now I'm thinking I need to allocate some arrays for this new output. I don't know the syntax for that, so I'm going to start Googling it now in Java. Okay, so that's how we do um, a new array of a certain type, and it initializes to 0. Okay, I'm gonna try this as I go along, and I'll talk about what I end up doing and why I end up doing what I do for code. I think I sometimes just don't talk, which is not as useful. So I'm going to write a new function for this. And what I want to return is a two-dimensional array. And they call it Reshape. The thing we pass in is input. And let's say that we have a const, that's JavaScript. I have no idea how I think it's like this. Let's see if this compiles at all. Yeah, great. So if you're doing an interview question, don't use languages you don't know, like what I'm currently doing. Pick the thing you're most familiar with. Okay, it's running. I will console log this. Or hopefully it's got a toString for arrays. That's right, it gives you the address. That's fun. So I'm just verifying that this function is actually being called, and I have the right syntax for iterating through things. Okay, great. So that works. And of course, let's see how they specified this. So if, of course, we have to find the initial, pardon my JavaScript here, we have to find the initial row and column height of the input. And as I said before, what is legal is essentially the area of the input has to be r times c. If it is not, just return the original input. Is it length? This might be a little frustrating to watch if you already know Java. Okay, it's dot length. That would be the rows. I'm guessing there's at least one, we have at least one row, and for each row we have at least one column. Otherwise, there would be 0 things in it. It doesn't say, so I'm going to assume that there is. If not, we can easily fix this after. We'll know when the test case exception's out, because this would be an exception. So if the area is not equal, return the original thing. Otherwise, allocate as many. How do they do this? Ah, gotcha. Okay, so that's exactly what I want. So I want R many rows and C many columns. And then I'm just going to return this without filling it in right now to see if I got the syntax right. I have to pass in, let's say, 1 and 4. That's right, there's no strict, everything is a strict equality in Java. Okay, that looks good. I expected one row of 4 zeros because I passed in 1 and 4. Cool. So now I will iterate through everything in the, let's see, so I could either iterate through the output and pluck what I need from the input and fill in the output, or iterate through the input and fill in the output. Seems like there's a little math here. Either way would work. It feels like it would make more sense to iterate through the input because that's what I'm given. That's what I need to start with. So row the input, and then for each, I actually want the index as well, because only with the index of the row and the column can I calculate the position in the output. Row index is less than and then for the same thing for column. This is actually dangerous to copy paste something like that. If I could easily have missed a row plus plus and then the whole code would just be wrong, but I wouldn't. It would take a while to debug because they all look the same. So now we know that the number on this row at this column is the one we want to fill. And the new row is, let's see, it would be however many rows we have already processed times how many items there are on each row. So for example, if we're looking at 3, then we've already processed 1 and 2. And that's one row and there's 2 items on that row. So we essentially want to find out, I guess I could have had a counter that increments on the inside so that I would know, but it's implicit in the 2 indices here. I can just multiply them out. I think this looks cleaner than having a global index because the math is here way more explicit. That says this is how I'm calculating which input this represents. So, or rather, this is the nth item. So this is the n. So maybe total item IDX index. IDX stands for index. It's just shorter to write. So this would increment, the value of this would essentially be 1 more every time we loop through the inner loop. And the output row would be that divided by the number of output rows. And I think Java integer division essentially gives you like a truncated version, right? So 1 divided by 3 is technically 0.3, but the result is always an integer, so it rounds down. And it never rounds up, only rounds down. Just making sure. Is that the integer returns the true result division rounded towards 0, right? So if it's negative, it's technically up towards the positive, but it's just closer to 0. It gets rid of what's in the decimal. So that gives me the row, and the column is the same thing, but modded by column. Let me see if I got this right. So if my item is the third item in this example, 1, 2, 3, 4, my new row is just 1, then divided by 1 is, that's not right then. It's actually divided by C, because I want to know how many sets of items could have fit before this item. So maybe a better example is if I had 4 by 4 before, and now I want 2 by 8, and my current IDX is, let's say, on the third row of before, so 9. That means the new one, 9 divided by 8 is 1. And this is an index, so this is on the second row. Well, 1, but second. And the column I want is 1, because 9 divided by 8, which is the C, is, or 9 mod that C is 1. That's what's left over. So that makes sense. Right. So what seemed weird to me a little bit, for a little bit just now, was I only used the variable C here instead of the R. So it was like, well, why did I care about R at all? Like, why is that part of the input if I'm not going to use it? The reason is I already used it up here to make sure that the number of items match. And so here, I'll put row IDX, put col IDX. Okay, that seems to work. Get rid of all this. Let me battle test it now. I mean, this is the real. They call it nums. That's okay. Okay, that looks alright. That's the same test example I had. Moment of truth. Okay, so it looks like this is right, and they didn't care about this at all. So that's it. This was pretty straightforward. It's pretty simple. It's actually just more math than anything else to see if you can manipulate enough, I guess, understand mod and division in computer science terms, because this is unintuitive, and depending on the language you use, it's not the default. In Java it is, but so you'd have to understand integer division and how to get the mod out of stuff like this. So in a way, Java actually simplified or forced my thinking here a little bit. If it was JavaScript, like this would just give me a floating point number. I think that, yeah. In which case I'd have to round down. I mean, it wouldn't be the default. It wouldn't be too hard to do, but it's something extra I'd have to do. Hopefully that was useful. I'm gonna totally do a hard one at some point.